Right, so we're going to do some triangle congruence with flowcharts, and then we'll look at some similar figures as well. So for this proof, we have our figure drawn, and we have the skeleton of our flowchart put together. So now we just have to fill everything in. So let's start with our given. It's a good place to start. So our given is that AB, line AB, is congruent to line BC. And so whenever possible, you want to mark that on your diagram. So let's do that. Right, so the single tick marks, since they're the same number of tick marks, that tells us that those lines are congruent. Next, we are also told that D is the midpoint of AC. So let's add that to our proof first, and then think about what we can add to our figure, that tells us about our figure. So we know that D is the midpoint of line AC, and we know that because it's given to us, right? So remember, in the bubble goes your statement, and then right next to it on sort of the bottom right for our flowcharts, that's where your reasoning goes. You always want to include your reasoning. Great. So because D is the midpoint of line AC, we can also say something else. Think about what the definition of a midpoint is. Right, so it's the point exactly in the center, which means that line AD and line DC are also congruent. So we can say that those two lines are congruent. And the reason for that is the definition of a midpoint. All right, so let's add our other given to our flowchart. So our other given was, again, that line AB is congruent to line BC. And the reason for that, what do you think? Where did we get that information? Right, so that was also given to us. All right, so we're always using our reasoning there. Last but not least, this one gets a little bit tricky because it's almost like playing a game of state the obvious, right? Of course it's true, so why say it? Well, for our proofs, we have to say it. So that's this line, line BD. It's part of both triangles, right? We're trying to prove that ABD is congruent to CBD. So here's ABD, and then here's CBD. And line BD is part of both of those. So we can say that line BD is congruent to line BD, right? State the obvious, but we need to. And that is the reflexive property. So remember, reflexive is almost like reflection. When you look in the mirror and see your reflection, you're seeing yourself. And the same goes with the reflexive property. You're saying that something is congruent to itself. So now that we have all these three pieces, we can bring them into our last statement. And your last statement is always what you're trying to prove. So the last bubble, the lowest bubble, should always be the thing you're trying to prove, which in this case is that triangle ABD is congruent to triangle CBD. So we're going to just add that to our last bubble. And why can we say that? Take a minute, see if you can remember the triangle congruence theorem based on the things we have. So we have this side, and this side. That's a clue. And in fact, it is side, 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 triangle congruence. So since all three sides of both of these triangles are congruent, then we have congruent triangles. Okay, let's keep going. So our next one is that given DB bisects ABC, angle ABC. So that's DB bisects ABC. Well, I'm just going to start with saying that in my first bubble. So line DB bisects angle ABC. And that's given. And because of what bisect means, right? Bi, like bicycle, two, and sect, like dissection, means cut. So to bisect means to cut in two. And for our purposes, bisect means cut exactly in half. So then I can say that angle ABD is congruent to angle CBD. And that's because of the definition of a bisector. So the definition of bisector. Okay, so let's add that to our diagram to make sure that we have our diagram as labeled as possible. So I'm going to put actually I'm going to put two arcs there because we already have a single arc elsewhere. And so two arcs there. Okay, so now we're all labeled up. We've dealt with our first given. Good to go. The next given is that angle A is congruent to angle C. And we can see that this has already been labeled in our diagram by these arcs. So I'm just going to add that to my flowchart, that angle A is congruent to angle C. And again, because we got that from our given information, we just say that the reason for that is given. Okay, last but not least, we need one more thing. So I'm going to sort of take stock of what I have. I have an angle. Good. I have, another angle. Now, in order to have a congruence theorem here, in order to use one of my 5 triangle congruence theorems, I need one side. Luckily, just like we had in our last proof, we have this side, BD. It's still part of both triangles, so we can still use our reflexive property to say that it's congruent to itself. All right, so we're going to say line BD, that looks like an O, line BD is congruent to line BD. And again, the reason for that is the reflexive property. Whenever you say that something is congruent to itself, that's the reflexive property. Okay, so now we have to bring all these together and make our statement of congruence. So here's the bringing it together, arrow, arrow, arrow. And we always take what we're trying to prove and put it in our final bubble. And so in this case, we're trying to prove that triangle ABD is congruent to triangle CBD. And when you're thinking about your triangle congruence theorems, you just think about what you have. You have an angle, and a side. So these triangles are congruent because of angle, angle, side congruence. Okay. So when you're doing these proofs, you want to start with what you're given, then label your diagram, see what else you can say, and finally bring them all together and say what you're trying to prove last. Right, let's look at another one. Ooh, this one is getting a little spicier. We have triangles inside a parallelogram. Whatever shall we do? Okay, so same diff. We have some given statements that line BC is congruent to line AD. And that's actually already labeled for us. BC is congruent to AD. And we also have that AB is congruent to CD. AB is congruent to CD. Notice that order, right? The order matters. So I'm going to add both of those as givens. Notice that we just have three starting blocks. So we kind of have most of our proof from our given and our proof. So our first given was that line BC is congruent to line AD. Again, always including the reasoning. Statement, reasoning. Our next given statement was that line AB is congruent to line CD. And again, that was also just given. And now, last but not least, what do we often use? Think. We've got a side and a side. So, how about this? Check that out. It's part of both triangles. So we can actually use our friendly old reflexive property again. So let's do that. So we're going to say that line CA is congruent to line AC. And that's, again, because of the reflexive property. Oops. Reflexive property. So, the reason I ordered it that way is because we have A, B, C, and so then CA would take us back to our original vertex there, vertice there. And then we have line AC because CDA, we want to end up back where we started. So because these triangles, this triangle was rotated around the center to form this triangle. It wasn't just reflected. We actually have to swap the order of these two. Okay, so last but not least, bring it all together. Arrow, arrow, arrow. And let's think about what we have. In this case, we have a side, and a third side. So what's going to be our triangle congruence theorem? See if you can come up with that on your own. Okay, so we've got what we're trying to prove. Triangle ABC is congruent to triangle CDA. And the reason for that is side, 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 triangle congruence. Right? We had three sides. That's the theorem we use. Okay. One more proof. Man, it's a lot of proofs, huh? You won't have so many proofs on your assessment, so don't worry too much about that. Okay, great. Last but not least, we only have our 3 and then our final. So again, should be a simple-ish proof. So first, we know that line AD is congruent to line DC. So let's label that, or it's already labeled. AD is congruent to DC. And we'll add that to our proof. So line AD is congruent to line DC. Next, we've got angle A is congruent to angle C. And again, that's already labeled here. So angle A is congruent to angle C. What did I forget to do for both of those? Yeah, I need my reasoning. See, they're empty. They're all lonely. So we got to add our reasoning. So this is because it's given. And shocker, this is also because it's given, right? We pulled them straight from our given statement. So that's going to be our reason. So this last one is a little bit tricky, but it's a fun one because we don't have any other things labeled, and we also don't have any more like this. There aren't that many more bubbles. We can't do a whole lot more before we get to what we're trying to prove, that the triangles are congruent. So we have to get a little creative because these figures are now joined by these crossing lines. So what do we know about this angle and this angle? What are those? They're vertical angles. We know they're vertical angles because we have two lines crossing each other, and these angles were made just from those two lines, and they're opposite each other. So vertical angles are also congruent. That's one of our angle properties that we learned for our previous concept quiz. So we can now say angle EDA is congruent to angle FDC, Oops, can't forget our symbols, FDC. And that's because they are vertical angles. Angles are congruent. Okay, so now what do we have here? We have a side, we have an angle, and we also have another angle. But we have to think about our order, because if we look at our figure, we have an angle here and an angle here, and then the side in between it. So, since the side is sandwiched between our two angles, I'm going to actually swap this and put this over here just so that our flow chart kind of matches our actual situation. I didn't see where that was going at first, but now that I can see that my side is between the two angles, I'm going to go ahead and put it between my two angles in the flow chart also. So we have arrow, arrow, arrow. Now we have all the things we need, because we can say that triangle ADE is congruent to triangle CDF because of angle, side, angle congruence, or triangle congruence. So take a minute, think to yourself, did that make sense? Were you able to follow along? Were you able to kind of predict what I was going to say? If so, great. You're probably in really good shape for this part of your assessment. If not, maybe rewatch this, try to practice with the checkpoints, with the work we've been doing for the last few weeks. And you can always go to office hours as well to get some one-on-one help. There's lots and lots of practice available for you. So make sure you take advantage of this, because doing proofs is something that just takes a lot of practice. So now let's do something that's not proofs. So before we jump into working with similar shapes, let's just do a quick review on how to use a proportion to isolate x to solve for our unknown. So right here, we've got 5/8 is equal to something over 100, to x over 100. So to isolate x, we're basically going to fraction bust. We're going to multiply both sides by each other's denominators. And you may have heard this called cross multiplying or cross multiply and divide. You're basically just clearing out the denominators. So I like to color code if you haven't already noticed. And I'm going to say that'll be 5 times 100 and 8 times x. So we'll have 5 times 100 because that was this 5, and from the numerator on the left and the 100 in the denominator on the right of the equal sign. Oops. Now, this is something that a lot of students forget, so make sure you remember this. This is going to be equal to. The equal sign does not disappear. It doesn't, vanish. So on our right, we're going to take our 8 from the denominator on the left fraction and the x from the numerator in the right fraction, and we get 8x. Then we solve. So this is going to be 500 equals 8x. To isolate x, since 8 is being multiplied by this x, we do the opposite. So the opposite of multiplication is division. Divided by 8, divided by 8. I'm going to move everybody over here so we have a little more room. Definitely try and show your work in logical steps. Make it follow one step underneath the next. It makes it easier for you to think through the process, and it makes it easier for us teachers to follow your work. If you make a small error, we can see that you still understand. Okay, so the 8's cancel out, and we get x on this side, and then 500 divided by 8. Well, we've got calculators, but let's just do that by hand, just for quick review. So 8 goes into 50 6 times, which is 48. We subtract that from 50 and we get 2. 8 goes into 20 twice, which is 16. We subtract that from 20 and we get 4 left over. Now we're out of zeros here, so I'm going to add a decimal and bring this 0 down. So 8 goes into 40 5 times exactly. And we have nothing left. So our x in this case must equal 62.5. So that's just cross multiplying and dividing. That's just isolating x. And so this is after you've set up your proportion from your similar figure. Now, I'm going to shrink this away a little bit. Okay. So for this second statement, how can we tell the triangles are similar? Be very thorough in your explanation. Include a triangle similarity statement. Well, let's think about what we have here. We know these lines are parallel, so that's worth noting. And we know they're parallel because of these arrows. This was a very common error on the concept quiz from concept quiz 1. You drew parallel lines. It was clear that you knew the lines were supposed to be parallel, but you didn't mark them as parallel. And so we're in the realm now where if it's not marked, we cannot assume that it is so. So we know these are parallel. Line AB is parallel to line DE because it's marked as parallel, not because it looks like it's parallel. So I'm just going to keep a note of that. So line AB is parallel to line DE. Okay, cool. I'm starting to think about angles. So, because, you know, triangles, angles, congruence, pretty helpful. I'm noticing that these lines cross, just like in one of our flowchart proofs from earlier. So these are vertical angles. So now we can say that these angles are congruent. So angle DCE is congruent to angle BCA. Angle BCA. Notice I have to be careful about the order, right? So this one like this and this one like this because they're not a reflection. So we have to think about the order there. So what else can we say? What do you think? So we can start to think about our angle relationships. So here's a transversal. I'm going to highlight this in green. So here's a transversal from two parallel lines. And so if we look at this angle and this angle, those are interior to the parallel lines and on alternate sides of the transversal. So those are alternate interior angles. And since the lines are parallel, alternate interior angles are congruent. So now we can say, now we can say that angle DEC is congruent to angle BAC because those are alternate interior angles. So you're thinking to yourself, wait, we have another transversal. I'm so glad you were thinking that because I certainly was as well. So here's our parallel lines again. We'll do them in orange. And here's our other transversal. So now we have this angle and this angle. And it would be so nice if they were congruent. And in fact, they are interior to the parallel lines and on alternating sides of the transversal, right? One is over here on top of the transversal, and the other is here below the transversal. So they are alternate interior angles again. And since our lines were marked as parallel, we can say that those angles are also congruent. So those angles, we would want to name them. Angle CBA is congruent to angle CDE. And really take your time to think about the order, right? You want to make sure you're saying what you think you're saying, that the transversal you're using is what you think you're using. So just be really careful with your proofs. Okay, so if we take stock of what we have now, we've got an angle, another angle, and last but not least, another angle. So for our similarity statement, we would say that triangle CAB is similar. Notice we ditch the little equal sign underneath because they're similar. They're not the same size, they're not congruent, but they have the same proportions. So this is what we use for similar. So triangle CAB is congruent. Oops, I lost one of my yellow angles. Is similar, careful, to triangle CED. And the reason for that similarity is angle, angle, angle similarity. And realistically, we only need 2 of those. All triangles add up to 180 degrees. That's the triangle angle sum theorem. So if we're at 180 degrees and we already know 2 of them, we don't really need the third one. But either way. All right, so angle, angle, similarity. Cool. So now for part 2 of this. So in the diagram from number 2, if AB equals 14, so I'm going to go ahead and label that. So AB equals 14 and AC equals 16 and DE equals 12, calculate CE. So I'm going to label that with an X so that I can set up a proportion and solve for X. Okay. So, well, I'm going to say the 12 and the 14 are the same side. So are corresponding sides on the similar triangle. So I'm going to make those into a fraction. So I'm going to say 12 over 14 is equal to, and then I need to be careful that since I took triangle CED and I put that in the numerator for my first fraction, I also need to put its side in the numerator for my second fraction. So I'll say x over 16. So again, 14 and 16 both came from triangle ABC, and both numbers are in my denominator. And 12 and x came from triangle CED, and both of those numbers are in my numerator. There's many different ways to set up proportions, but the components of one triangle have to be either vertical or horizontal with each other. They just can't be catty corner. So as long as this 12 and this x are next to each other like this, or we could set it up like this. Right? As long as they are not diagonal, we're good. But I'm just going to solve it one way. Now, personally, I like to reduce fractions before I start multiplying because I like to multiply with smaller numbers. So 12 over 14, we can reduce both of those numbers by 2. So this will become a 6 and this will become a 7. I'm going to rewrite my fraction just to make it a little easier to use. So 6 over 7 is equal to x over 16. Now, once again, I'm going to cross multiply. So 6 times 16 and then 7 times x. So we've got, I'm going to say 7x is equal to, remember your equal sign, 6 times 16. So 6 times 6 is 36. 6 times 10 is 60. 36 and 60 is 96. Last but not least, we are going to divide by 7. So we can isolate x. So x equals, I'll do it out, goes in 1 time with 2 left over, and goes in 3 times with 5 left over and 7 times. So x is, I'm just going to leave it there. I'm going to be a little lazy. X is about equal to 13.7. Now, before I just move on, right, that's what x equals according to my math, I want to double check that that makes sense. Because sometimes we do our calculations, our calculator gives us a number, and we just run with it, but it's silly. Like a person is negative 10 feet tall, right? Obviously not, but our calculator said it, so sometimes we miss it. So if I look at my diagram here, 14 and 16 are pretty close to one another, and 16 is just a little bit bigger. So 12 and x should be pretty close to one another also, and x should be a little bit bigger. So is 13.7 a little bigger than 12? Yeah, I would say so. That's reasonable. We're in the ballpark. So when you're asked, is this a reasonable answer? That's kind of what you're looking for. Like, is this in the realm of possibility? Okay, let's keep going. So in the diagram, triangle ABC and ADE are similar. If AB equals 6, okay, we're going to start labeling. AB equals 6, and BD equals 4, and BC equals 7, then what is DE? That's our question mark. That's where we're going to put our x. You can use any variable you want. We're just going to use x. So let's think about the proportion we can set up. And for this one, we want to be careful because our small triangle is ABC. So we can set up our proportion from the 6 and the 7 right there. So we can say that 6 over 7 is equal to, now, 6 was this side. So we want to use that side of the big triangle, which is A to D, all of it. So we don't want to use just the 4. We want to use the 6 plus 4 because that whole length is that side of the big triangle. So I'm going to write that for now as 6 plus 4 just because it's important that you remember that it's both of those pieces together because we're looking for something about the big triangle. So then our unknown, right, our base is x. So we'll just plop an x in there. Okay. So now I'm going to make this 6 plus 4 equal a 10. And who'd have thunk? We're going to cross multiply. So we've got 6 times x, and we've got 7 times 10. So we get 6x equals 70. If we divide by 6, we get x equals, let's do it. 70 divided by 6. 6 goes into 7 one time. Subtract it. We get 1 left over. Bring the 0 down. 6 goes into 10 one more time. That's 6. We subtract it. We get 4. We need some decimals here. Lucky us. We're going to bring down this 0. 6 goes into 40 6 times, which is 36. And check this out. So we're just going to keep getting 40 and 40 and 40. So we're going to say that's 6 repeating. And so let's think about that. Does it make sense for x to equal 11.6 repeating, or 11 2/3? Well, yeah, I think so. This side is 10, and this side then would be a little more than 11, a little bit bigger than 10. If we look at our small triangle where they gave us both of the sides, we had a 6 and then a 7. And so our base was, again, just a little bit bigger than our side. So that's a reasonable relationship to have. So we can feel confident that we've set up our similar triangles and our proportions correctly and have a correct answer. All right, a few more. So let's do it. Now we are beyond triangles. So these two shapes are similar. We're going to solve for x. I'm going to highlight where x is. Boom, we're looking for u. All right. take a second, try to set up a proportion that you could use to solve for x. Okay. If you still need more time, just pause this. Take a moment, really try and set it up on your own. It'll be good practice. Did you set it up? Do you have something written on your paper? Are you taking good notes? Okay, so let's try something. Again, Ms. Jacobs is lazy. I'm going to use the smallest numbers I can. So I'm going to look at this 4 and this 10. Those are corresponding sides on these similar figures. And they told us that these figures are similar, so we don't have to prove that. So I'm going to say 4 over 10. So that's this shape over this shape is equal. Now I'm looking for the base. I'm looking for the bottom there. So I'm going to use this bottom here. And since the 4 was in the numerator in my left fraction, I'm going to put the 10 from the same shape in the numerator for my right fraction. So I'm going to say is to 10 over x. It's a funny noise. Okay. Surprise, surprise. Now it's time to cross multiply. Loop and loop. Cool. So we get 4x is equal to 10 times 10, which is 100. Isolate x by undoing the multiplied by 4. So we divide by 4 on both sides. And we get x equals 25. 100 divided by 4 is 25. Cool. Does that seem like a reasonable length for x? Why? Pause this and think about that to yourself. Is 25 a reasonable length for this? What could you compare it to kind of gut check? All right, so the way I'm sort of thinking about it is on our known figure, 10 is a little smaller than 12. So since on the big figure, 30 corresponds to this 12, we need a number here that's a little smaller than 30. And 25 fits that bill. It's a little smaller than 30. Okay. Last one. A rectangle has length 10 feet and width 6 feet. Okay. Let me tell you something. If they talk about a shape in a problem and they don't give you a picture of a shape, you must draw it. Very few times you'll be able to do this without drawing the picture, but more often than not, if you don't draw the picture, you're going to make a mistake. And just don't put yourself in that position. Just when in doubt, draw it out. So, all right, cool. It's not beautiful, but it will work. It doesn't have to be art. So the length is 10 feet, so I'm going to label it. And the width is 6 feet. I'm going to label that too. Then it's enlarged to a similar rectangle with a length 18 feet. Oh, a second rectangle? What do you think we should do? Is that, oh, we should draw another rectangle? I know, I'm getting strange. We've been doing this for a minute, so. Okay. So, our length was originally 10 feet. So now the length is 18 feet. I need to make sure I put that 18 in the same spot, right? It needs to be the corresponding side with 10. And then we're solving for the new width. So I'll put my x here. Great, so it says start by drawing a picture and labeling it. We did that. I like to draw my pictures and sort of take stock of my information as I go, so that I don't make any assumptions. Cool. Now we set up a proportion. Take a minute, try setting up your own proportion. So go ahead and pause this, write down in your notebook a proportion that we could use to solve for x. Okay, so hopefully you took a minute and did that. Let's see. So we've got, I'm going to say 10 over 18 is equal to 6 over x. Again, there are a lot of different ways we can set up the proportion, but as long as the pieces that are corresponding are either vertical with each other or horizontal with each other, you're good to go. So then we cross multiply. So 10 times x is going to be 10x. 6 times 18, well, 6 times 8 is 48. 6 times 10 is 60. 60 and 48 make 108. So then to isolate x, we divide by 10 on both sides. And dividing by 10 is so nice because we can just move that decimal right over. So we get x equals 10.8. So I'm going to write that in over here. So if this is 10.8, does that make sense? So here's how I sort of think through checking that. If I double 6, I get to a little more than 10. And if I doubled 10.8, I would get to a little more than 18, right? So our width is a little more than half of our length in both cases. So we're good to go. We have a reasonable answer. All right, I hope that was helpful. I apologize for talking so much, but have fun with your studying. Go to office hours for your teacher if you have questions. Even if you're not sure if you have questions, you can just come to office hours, do some work, ask questions as they come up. Just make sure. Because only perfect practice makes perfect.